our semester 1 material for chemistry. For the periodic table, that is where we're going to start. So there's horizontal rows on your periodic table when you look at it. Okay, so that's going to be rows going like this. Okay, those are going to be called our periods. Okay, so our periods, and they tell us how many energy levels. Okay, so energy levels that an element has. Now, energy levels, when you look at your periodic table, you will see the numbers to the side. So it goes 1 through 7, and you can see each of them on how they have their individual energy levels. Now, when you look at it, the vertical, okay, so these are columns, okay, these are known as our groups and families, okay, groups, families, okay, and they tell us how many valence electrons each element has, okay. Now, also, you have similar properties, so anything in this last group here, okay, in that column, everything's going to be the same. So everything. So if you look at it, for example, for our helium, neon, argon, all that's going to have the same amount of valence electrons, same reactivity. If there's any for these, they're noble gases, so they aren't. So has a similar property. Same thing for you for fluorine and chlorine. Okay, all that's going to be very similar. Okay. Now, valence electrons are how many electrons in an element's outermost shell, okay, determined by, again, your column and groups, okay, and you can see this table here. So in group 1, we know there's 1, 2, then we go to group 13, 3, 4, 5, 6, 7, 8. So it goes across from 13 to 18. Then the portion in the middle, those are your transition elements, and those do not have a set number for your valence electrons, okay, so that's why we skip that and we come back to it when we go to name. So, if we look at this, we can see how this goes. So, group 1, group 2, okay, group 1 will have 1, group 2 will have 2, 13 will have 3, 14 is right here, okay, will have 4, 15 will have 5, 16, 6, 17, 7, and 18, 8. So, you can easily see how this is aligned on the table above. Now, let's do some practice problems with that. Oh, in addition, alkali metals are going to be here. Your alkaline earth metals are in group 2, and then halogens specifically will be in group 17, and noble gases in group 18. When we look at this, we can see we have these two that are designated, okay, so your noble gases, halogens. Then we have your alkaline earth metals and alkali metals. Now, anything left of the zigzag, okay, are your metals. Anything to the right are your non-metals, okay, and you can see how I have listed that above here. So metals on the side, non-metals on this side, okay. So when we look at this, it says which compound contains an alkali metal and a halogen. Well, alkali is group 1, okay, and our halogen is going to be in group 17. So when we look at this, we can see, okay, we have RB and I. RB is your alkali, it's in that group 1, okay, and I, okay, is right here. It's our halogens in group 17. So we can say for number 1, it is B. Okay. Now, number 3, which element would have properties that are similar to barium? Now, barium is going to be in our group 2, okay, that column. So any other element listed here is going to be our answer. So when we look at this, we can see that SR, okay, which is right above BA, is our answer, okay. Now, we talk about charges for our elements, okay. Same thing with our valence electrons, except this time we go through and we give them specific charges. So our group 1 will have a +1, group 2 is a +2. Again, we're not using our transition elements because we have to specify it differently. They could be multiple different charges. So therefore, that's why we skip them. I'll show you a way shortly about how to determine that. Then you go to group 13, which is +3, ±4, -3, -2, -1, and then of course our noble gases are going to be 0. So when you're looking at your metal, you see that we're on this side, okay, the left side of our zigzag. So we have 1, 2, and 3 are designated. So what's happening is that we want to make it stable. So when we make it stable, you have 8, okay, or you go back to 0, okay, 0, which initially will bring you back to 8 in the long run. So what you want to do as a metal is you want to get rid of those, okay, because there's not very many, so it's easier to get rid of 1 or 2 than to add, 6 or 7, okay, so in order to make 8, so it's a lot more energy to add more. So we want to get rid of them. So we want to make actually 0, and we want to lose those electrons, okay. When we do that, we lose our negativity, so it becomes positive, and we call them cations. Now our nonmetals are on the other side, and you can see their valence electrons, okay, if we pull this back up here, our valence electrons are going to be like 5, 6, 7, 8. So it's a lot easier, okay, with 5, 6, 7 to add 1 or 2, okay, and less energy than having to get rid of the 5 or 6 or 7. So initially we want to go towards 8, and we want to gain, okay, those last few that we need. And when we do that, when we gain negativity, okay, we become more negative overall, and we're called anions. Okay. Now, when we do that, we can practice using our charges so that when we go to write our equations and our formulas. So when we look at this, we have to identify what is what. So we know, for example, here we have potassium, okay, it's a metal, okay, it's a metal. We can see that because it's located right here, okay, it's on the left, okay, so that is our potassium. We see that it has 1 valence electron, okay, because it's in that first column, okay, it has that 1 valence electron. And so we see that it's going to lose because it's a metal, okay, so how many are going to lose? We're going to lose just that 1, so we have K plus 1, and we know it's a cation. So if we look at fluorine, fluorine is located in second to last column, so that's group 17. We know that has 7 valence electrons, okay, so 7 valence electrons, and we know it's a non-metal because it's on the right-hand side, okay, of that zigzag. So non-metal, okay, how many? We have 7. What are we going to do? We're going to gain them because it's easier to gain 1 than to lose 7. So we're going to gain 1. So when we write this, okay, we're getting a negative electron, so we become a negative 1. And because we're negative, we're called an anion. So that again is for fluorine. My apologies, I wrote it on the wrong line. Okay, so that is for fluorine. So take the time, hit pause, finish the last few questions, and then hit play when you're ready to resume. Moving on to Roman numerals, okay? Elements in the exception block. That's going to be this right here. The reason why we call, your transition elements. So these are your exception blocks. So the elements here are your transition elements. Your exception block is right here. The reason why these are exceptions is because they have determined charges. They don't change, okay? So these won't change, but your transition elements will. So when we list those, we can say, okay, it is Al, Cn, Ca, Ag, Cd, In. Okay? Now why the exceptions? Because their charges don't change. Okay? Now, do they need Roman numerals? No. Okay? Because we already know what they are. And they only need Roman numerals because we don't know. We have to figure it out and solve for it. So, binary. Binary means they have 2, because bi means 2. So you can see here you have 2 elements attached. So when we go to name it, we have to go back through and see what it is. So we have FeBr3. Well, we know Fe is a metal, okay? It is located to the left-hand side of our zigzag, okay? And it's not in our exception block, meaning we have to give it a Roman numeral, okay? How we do that is we have to solve backwards. We look at our Br, and we see that it has a -1 charge, okay? So we write that down, okay? It's a -1 times 3 gives us a -3 overall. Well, we have to make 0, cancel it out. By doing so, we do a +3 to our iron. So when we write this, it's going to be iron 3, okay, meaning that +3, and then we say bromide, okay? We change that bromine, okay, to bromide. Alright? Now let's look at this one here. This is barium, Ba, okay? We look at Ba. Ba, okay, is not a transition element, okay? But we can look and say, hey, we do know it's charged, okay? It does give us a value, so we know it's a +2. So we don't have to write Roman numerals. So when we go over here, we can sit there and say, okay, well, we're just going to name it, okay, our barium. And then next we have iodine, okay? So iodine becomes iodide. So just name it right as we see it, barium iodide. Now finish the rest. You can pause, take a moment to do that, and then when you're ready, hit play again. Moving on to writing the formula. Writing the formula, you have to sit there and write your symbol with your charge. So lithium, we know, is Li, okay? And we know phosphorus is Rp. So when we look at our periodic table, we can see, okay, well, our Li, okay, has a +1 charge. And then we can look over here, because that's our metal. And then our non-metal is Rp, or phosphorus. And we look up here and we say, hey, it has a -3 charge. So we say a +1, -3. Now, in order to solve, we have to crisscross. So we take this and we say this is Li3, we get 3 Li's. Then we take the 1 and we give that to our phosphorus. Okay, so our phosphorus, it's 1 here, but we don't write 1. Okay, so just having the symbol means it's 1. Now when we just combine it together and we put this on the line, and that's our formula. Now, right here, if you look at chromium 2 oxide, okay, this 2 tells me that my chromium is a +2. Okay, it's always a positive number. Now, when we look at our oxygen, we have to sit there and go and find what it is. So if we look over here, we see oxygen is a -2. So we have a -2 value. So when we write this, we write it as your Cr2O2. But it's not in lowest terms. We can divide each of these by 2, so we end up writing CrO as our answer. Okay? So let's work the rest of these problems. Hit pause, and when you're ready to resume, then you may continue to the next section. Okay, so for ternary compounds. Ternary compounds mean it has to be at least 3 or more elements. So you can see how it's FeCN, okay? All these here, so we can see that. Now, Fe again is our iron, our transition, okay, a transition element here. Therefore, it doesn't have a definite charge, okay, and it's not part of our exception block, meaning we have to find what it is, what charge it is to write down. Okay, now we will look at our cyanide. So we know cyanide, okay, is our Cn, and it's a -1. Okay, so when we look at our table down here of our polyatomic ions, we see cyanide is that. So we look and say, okay, well, we know cyanide is a -1. Again, we have to make it equal, so that makes it a -4 overall. So this one's going to be a +4. So when we write this, it'll be iron 4 cyanide. Now let's look over here. We have Na. Na, when we look at our periodic table, okay, is sodium. Okay. Then we have NO2. So we look at our polyatomic ions. So NO2 we know is nitrite, okay, which is a -1 charge. So we go over here and say, okay, we are good there. And the reason why the other thing too to look at is, first of all, is sodium a transition element? Sodium's here, so it's not a transition element, meaning we don't have to even worry about our Roman numerals, okay? And also it cancels it out, so this is a +1 and that NO2 is a -1. So we just write it as it is, sodium nitrite. Okay. Finish the rest, hit pause, and when you're ready, you may resume. So writing the formula. Again, we use these Roman numerals, okay? So we know lead is a +2 because it told us it was 2, and it's always positive. Now acetate, we see C2H3O2, and we have to look at our polyatomic ions, and we see here acetate has a -1 charge. So we say, okay, we know it's a -1, so now we have to crisscross, okay? So we give the 1 to our PB, and it stays by itself, and we don't write 1s. Then we have to give the 2 to our acetate. So really it's going to be C2H3O2 to the second power. Okay, then we combine that over here on our line. So Pb C2H3O2 2. Now let's look at this one. This potassium phosphite. Potassium, okay, that's our metal, and it's a K. We know it has a +1 charge. Okay. Now phosphate is PO3 -3. So we write that down. So we have our K +1, our PO3 -3. Okay, so we're going to do the same thing. Give our 3 over here, so it's K3, and the 1 goes over here, so you have 1. So we do our K3, PO3. Okay, so hit pause and to complete this section, and when you're ready, hit play to resume. Now, as we're doing this, we also need to tell the difference between our ionic and covalent compounds and molecules. So we have to know what each of their properties. So we know ionic has metals. So it's going to be a metal attached with a nonmetal. Okay, it always transfers its electrons, and it conducts electricity. Now, some of them may require, if it's not an exception block and in that transition element, then it will need a Roman numeral. Now, for our nonmetals, which is our covalent, it has only nonmetals, nothing but nonmetals. There's no metals at all. And because of that, they have to share their electrons, and they aren't very good conductors. Okay. Now, when we do our covalent, we have to use prefixes. Okay. We always like the mono, tri, di-tri. Okay. We go in order. Okay, with our in tetra. All those are prefixes, examples. So let's identify the difference here. Okay. It tells us circle the metal in each formula and then identifies ionic or covalent. So for this one, we know sodium is our metal. Okay. Calcium is our metal. Okay, and lithium. And the reason why we know that is because of where they are. So we see sodium, calcium, and lithium. Those are all metals. Now the other one that was listed was our carbon. Okay, carbon is over here. It's to the right of our zigzag, so we know it's a nonmetal. So we don't circle it. Where you have circled, you now can say that it's ionic. So everywhere you have one that is circled, you say ionic. Okay, because that is your metal with your nonmetal. Now the one you didn't circle, that's a nonmetal, so therefore we say it's covalent. You can put a C. Okay? Hit pause and finish this section, and when you're ready, hit play to continue. Now moles. 1 mole is 6.02 times 10 to the 23rd atoms, which is also the same thing as 6.02 times 10 to the 23rd molecules. Okay, so anytime you see 1 mole of atoms or molecules, it's always going to be the same value here, the 6.02 times 10 to the 23rd. Now hit pause and complete this section, and hit play when you're ready to resume. Now the last section here is molar mass. Molar mass can be found from the atomic mass on the periodic table. Okay? So your atomic mass, meaning it's these values, okay, right here. That's what you're going to use. Now, you have 2 problems here. The first one will work together. So you have aluminum and oxygen, so aluminum oxide. So when we do this, we say, okay, first of all, how many aluminums do we have? It tells us we have 2 aluminum. So we say, okay, 2, okay, times what our value for aluminum, which is 26.982. So 26.982. Okay, and when we multiply that together, we get our value of 53.964. Okay, now the other part is the oxygen. It tells us we have 3, so we do 3 times 15.999, and that gives us 47.997. Okay. Once we have those 2 parts done, we add them together. And when we do that, we get 101.961 grams per mole. That is going to be your unit, grams per mole, for our molar mass. Okay, so you basically count how many atoms you have of each, multiply by their atomic masses on the periodic table, and then you add up all together, sum it all together. So please finish this last problem. If you have questions, please ask your teacher, and complete. Thank you so much.